Hello guys and welcome to Unity Tips video series. In the previous video we talked about how singletons can be useful in Unity despite their drawbacks. In this video we will look at a Unity specific implementation of the singleton pattern. I am the creator of the game called Snappy Mouse Run, and if you heard about the so-called MonoSingleton class, then this one might be familiar to you. This is a slightly modified version of the MonoSingleton class that you might already know about. If you don't worry, we'll walk it through. If you are more interested in its application, then you can fast forward to a specific timestamp in the description. The most important part is the single static instance property that is accessible from any other class. It makes this one a singleton. Then we have a setInstance method which sets this instance. It is called when the instance property is first accessed. That's why those question marks are here. They are checking if the instance is null. If not null, the instance is returned. If null, then the code behind is returned. In our case, the result of the setInstance method. The method takes a newly created game object with an attached component that will become the new singleton instance. The new game object is created by the create method, which also checks if the component instance already exists on the game object and creates one if it doesn't. Why would a component exist on an empty game object, you ask? In fact, the transform component is always added to every new game object by default, so this case is covered. The setInstance then first checks if the instance is already assigned. If not, assigns the new one to it. Then the don'tDestroyOnLoad method makes sure the singleton is accessible across all scenes and the instance is returned. This part is basically the same as other MonoSingleton implementations out there, just in a more compact form. So far so good. This part where we create the new game object may confuse you thinking we're creating the new one inside of an already existing one, but that is actually not the case because of those static modifiers. The easiest way to think about statics is to imagine the static part to be outside of the object rather than a part of the object itself. These static members are not bound to the concrete object in any way and work as if they see the concrete object from the outside like any other class on the outside would do. Now let's see what is part of the concrete object. If we look at the class definition, we can see that this isn't a typical mono behavior. It is defined as abstract, what means that the class needs to be inherited from other classes to work. Also, there is this strange generic part, the instance with its condition, that will also be defined by the inherited class and will eventually become our singleton instance type. According to the condition, the generic type has to be a component. So it can be a transform, a script, camera, animation, audio, basically anything as long as it is a component. This component will then be created together with the game object when the singleton instance is first accessed. But what if we already have a game object with the component in the scene? In that case, this code would create another one. We need to make sure that only a single instance exists. This is where the object's_awake method comes into play. Despite the additional modifiers, protected and virtual, this is Unity's monoBehaviorAwake method that will be called by the engine when the game object becomes active for the first time. So at the scene start, the object's_awake method will check if the singleton instance is empty and in that case set itself as the instance. Once the singleton instance has been set by the first object, every other instance is self-destroyed by its own awake method. This ensures that only a single instance exists across all scenes. So much for the walkthrough. Let's see how this singleton implementation can be used. As said, the singleton instance can be any component. Since a monoBehavior script is a component, we'll look at it first. First step is to inherit the class from the MonoSingleton and set the class name as its generic type. So the singleton instance is of this type. Second step is to override the awake method. Inside, make sure to call the base awake method from the MonoSingleton and afterwards check if the instance has been destroyed. If it was destroyed, then there's already been one created and we don't need this one anyways, so just return. Otherwise, if this is the one that was set as the singleton instance, then we continue and fill the rest of the awake method with the actual initialization like in any normal monoBehavior class. The singleton part is handled, the rest of the class is up to you. So it's pretty easy to set up a MonoSingleton or to convert an ordinary monoBehavior to a MonoSingleton if you follow this pattern. A good singleton example is the debug console like this one used in the game Snappy Mouse Run. Same pattern, inherited from MonoSingleton with the generic type and overridden awake. Everything else, including the last line of the awake method, has nothing to do with the singleton part, but is the actual debug console logic. From the outside, you can easily access the debug console by just accessing the static instance property. This line will either create a new debug console if accessed for the first time, or will use the already assigned instance if it existed in the scene. No matter how many instances of the class you create in the scene, purposely or accidentally, in the end you always end up with a single instance that's accessible across all scenes. That was a straightforward example. Let's look at a more complex one where the instance isn't a mono behavior. Let's say we want a Singleton UI canvas instance. I have chosen a canvas because it's one of those components that you usually want to have access to. The camera would be another good example. In case we want a single canvas instance, something interesting will happen. Our class will act as a Singleton consumer rather than a typical Singleton class. So I'll call the class CanvasConsumer, inherit from MonoSingleton, and set the instance type to UI canvas. Override the awake method, but this time we don't want to call base awake. Calling it would not work since the generic type does not match with the class. By avoiding awake, we allow multiple canvas consumers in the scene, but at the same time the canvas instance is still only a single one created when the instance property is first accessed. We can use the awake method to initialize both the canvas instance and the consumer. The canvas needs to be initialized only once by the first consumer. Let's say the consumers are UI elements on the canvas. If there are no child objects on the canvas, then this must be the first awake method called by the first consumer. In that case, we will initialize the canvas. We'll simply group the consumers under a game object called consumers that will be the first child of the canvas. It should have a content size filter, so it's resized to match the content. The content will be the consumers and we will organize them with a grid layout group in one column. Each consumer will get its own 200 by 200 cell. Adjust the anchors and also will add the ability to scroll through the consumers using the scroll rect component. That's it for the canvas part. What's left is to hang the consumers onto the first child of the canvas, and that's all for the consumer part. To use the script, create a UI element, for example a button. I'll make it red, we don't need text, and attach the CanvasConsumer script to it. If we run the scene, there is our red 200 by 200 button and it sits on the Singleton canvas scene in the hierarchy. So the Singleton canvas was created and configured on the fly. Let's add multiple consumers. I will duplicate the button and change its color, duplicate again, change color, and duplicate some more. Now we have about 25 buttons in the hierarchy. Run the scene. We see all our buttons are in a single column and now we can scroll through them. In the hierarchy, we can see that all the buttons are under the Singleton canvas, and although we have multiple consumers instances, the canvas remains a single instance, no matter how many consumers we create. We also don't need to worry about the canvas setup anymore. Everything is auto-configured once a consumer is present in the scene. And of course, the Singleton canvas instance is accessible to all other classes, not only to consumers. This was a 2D example. Moving on to a 3D example. Let's say we want to rotate objects around the center. The center could be a Singleton and the objects its consumers. Following the same pattern, we create a consumer which is a MonoSingleton and has a transform as its Singleton instance. This transform will be our center. Then we override the awake method, and since this is also a consumer, we don't call the base awake. Transform instance defaults are good enough, so this time there is no instance initialization needed and we can begin to initialize the consumer. We need to define an axis around which it spins. It should have a radius and speed, and we will save its current orbit position. Start position will be a random position on a sphere with the given radius, where the Singleton instance position is the center. The random axis is a bit more complicated to determine, but it should be any axis that's perpendicular to the chosen start orbit position. If you're more interested in the math behind it, I can explain it in another video. Once we have the initial position and axis, we can start rotating the object in the update method. The new orbit position is the current position rotated around the axis with the given speed, and like in the awake method, we want that it rotates around the instance position. That's all for the consumer part. To use the script in the scene, create, for example, a sphere and add the script to it. Start the scene. The sphere is rotating around the instance. The instance is just an empty game object and the consumer is not parented to the instance. It just follows it and rotates around it. Now let's duplicate the sphere a couple hundred times and we get a bunch of random rotating spheres around the Singleton instance. And it looks nice and interesting. So I hope you now have a better understanding of how the Singleton pattern works and also have an idea how to use them. In the next video we will make the sphere example even cooler by implementing some physics, and for that we will use some interesting tricks from the engineering domain, which I guess not many game developers know of. Thank you very much for watching. Give a like and subscribe if you want to see more videos like this one. Press the bell icon to get notified when I release new videos, and I also very much appreciate every feedback I get, so feel free to comment. See you in the next one. Bye.